Doug,
you're still muted.
Okay, welcome everyone
Not a problem.
to Robot Builders Night Virtual for June 3rd, 2025. And usual agenda, DPRG news, and we may not have a queue tonight, and then open mic. So DPRG news. We just discussed the website and still struggling with it. Date for a power lunch. We should have a power lunch here, like towards the end of this month. And thoughts. It seemed. Let's see. Who's on the call? Who would come? I think Mark and Doug are probably about it. So
I'm leaving after the 19th.
okay.
Okay. So if you have it before the 19th, then I can go.
Yeah.
Okay. Well, so Kareem and Dave Ackley are just joining, so let's let them weigh in. Hi, Dave. Hi, Kareem. You guys hear
Hey
us?
guys, I got nothing.
We're talking about food, Kareem.
Oh, food. Okay.
A power lunch.
No queue for me, but you're talking about the
Power
lunch
lunch
thing?
Yeah.
Our lunch? Okay.
Yeah. So
I'll eat anything.
Doug said he's leaving on the 19th, so we'd need to do it before that. If we did it on the Sunday, that could be the 15th. Other than that,
Sunday's
sort
good for
of
me.
thinking, well,
Yeah.
maybe the 29th, Sunday the 29th. Dave, Kareem, do you guys have any input on that?
I could go either way.
Okay. Doesn't seem like Dave's
Dave's busy.
listening to us. So why don't we declare it for the 13th, for the 13th of June?
That's
in
Friday?
1 week. It's a Sunday?
Oh, 15. Yeah, 15 Sunday.
Okay.
15th.
Yeah.
Would be a Sunday.
Am I on the wrong month?
June?
Maybe you're on the wrong year.
June 2025.
That's why you're having problems with the certificate.
Wrong month. Yeah, 15th. Yeah, I mean, what do you guys think about the Sunday versus having it on a weekday lunch? I mean,
Definitely.
Sunday works better for people who are working.
Right.
So I went to an English pub called the Derbyshire up in Frisco the other day, and I thought that was fun with English ales, English food. But we could move it down into Beltline. There's a flying saucer down there, I believe, which I don't know what they have in the way of meeting rooms, but the Derbyshire had a segregated room that we could take. Any thoughts?
I mean, it sounds good to the Brit.
I won't be able to make it.
One of these days we'll get you down here, Pat. Okay, well,
Possibly after your leader is gone.
We should try and find a Canadian restaurant down here, get some poutine and some good food.
Yeah.
Poutine and beaver tails.
Beaver tails.
Okay, well, let's declare it to be on the 15th at the Derbyshire in Frisco, and I'll publicize that. And then we've got on the 28th, we've got the tour of Robot Lab coming up, so we'll advertise that. Then the other the other DPRG thing was I did my talk for the HBRC Homebrew Robotics Club, and you may have seen a few of those folks join our Discord. I got some really good, positive, neat, cool feedback. Several, I got a couple of contacts afterwards saying people enjoyed it, and the people joining the Discord sort of speaks to that. So that made me feel good. The talk on the DPRG part went well, but the talk on the Lena Robot part went especially well. Enough that one of the guys that attends the Sunday call on Lena Robot contacted me and about a donkey car, putting Lena Robot on a donkey car, and which led me to a rather sad realization that Lena Robot 2 doesn't support Ackermann drive vehicles. It's really built, it's really designed and configured. Its configuration is all around differential drive or skid steer or Ackermann, but not, I'm sorry, I said Ackermann, I mean Mecanum wheel drive, but not Ackermann. So,
But
anyway.
if you're, recording, the values of, differential steering to two speeds, can that be translated to?
Yeah, it
just
could.
direction and speed.
Because the message that goes down, the message that goes down to the micro ROS is contains forward direction and angular rotation velocity. So that can clearly be changed into steering angle within feasibility limits, obviously, and motor drive speed. But as it's built right now, it does not cover that kind of a robot. Anyway, so that was that. So with that, let's just jump into open mic, and if I can get my demo, so I guess I'll lead off open mic with the latest project is to somehow unify Thomas Chu's fork with the upstream fork of LinoRobot, and I've been working on that, and part of that was getting the upstream LinoRobot fork working on Jazzy, because it had broken. Because it turns out that the NAV2 team are releasing new navigation software into the Jazzy release of ROS monthly, approximately, and they break stuff all the time. And so it had broken LinoRobot since it was last tested and released. So I'm working with had a meeting with the guy who owns that repo, the upstream repo, and he seemed amenable to accepting a pull request that fixes it. So we'll see how I get on merging those forked repos. So LinoRobot is what I used on my mini bot in Roborama. And one of the things that I just got going over the last few days was getting LinoRobot working on the latest Jazzy release. But tonight it won't work, and I don't know why. Maybe, well, I don't know. ROS update of ROS got broken because they changed the certificate expired. So now you can't do an update until you fix that. It's just like the world is in a bad place at the moment. So I'm in a sad state, so I'll hand it off to someone with happier news.
I had a question. Is Scott's robot that he used for 6CAN, is that ROS based or no?
No.
No? Okay.
No.
Do you think, I mean, he's got like just over a 2-minute time for, I think 2 minutes and 4 seconds or 5 seconds for the, to complete the competition. Do you think ROS is ever going to be competitive in that? Because, I mean, you guys were like at 5 minutes and you weren't even partway through it, right?
I wasn't, but I had a really bad bug. But I think Mike did a lot better. He was around 3 minutes.
Okay.
So I would hope that there's room to improve. I mean, they drive
Mike was
cars
at 4
around.
minutes.
With that, then?
Mike was around 4 minutes.
Oh, was
Oh,
it
4
4?
minutes.
Yeah.
Because mine was around 3 minutes.
Oh,
Okay, so yeah, and I believe if you look in the Hall of Fame, I want to say the best time on a Scott robot was like 1 minute and 55 seconds, but you'd have to look it up.
Mm.
So he did algorithm changes because we stuck one. He couldn't get one of the cans, and I think it slowed him down a little bit. So, but
That's okay. It's what do they call that? Suffering from delusions of grandeur. I thought one of my robots was like 1.5 minutes. It's actually 2.5 minutes.
Yeah.
So it's like,
yeah.
oops.
that's pretty good, though. I mean, that's not
Yeah.
shabby.
Yeah.
Yeah, I would have taken third this time.
Mm-hmm.
So
Yep.
That's like I say, it just takes people to get it out and do it.
Push the limits of it.
Yeah.
I don't
Yeah,
think
yeah.
anybody's hit the performance limits of ROS inherently. It's just
Yeah.
particular implementation, and you might question the decision to use nav2 for this particular kind of for the high level control for this kind of application. I don't think that that's necessarily an optimal fit. It's meant for different kinds of problems, more general
Yeah,
purpose
that's a good point.
things. So there's no way you're going to
Yeah.
truly optimize it using nav2 natively, I don't think.
Yeah.
Yeah.
Yeah. I just kind of wondered. I mean, it's,
Yeah.
obviously it does a lot of things, and
You may still want to do it that way just because you're exercising your ability to implement with nav2, right, for those extended cases. So that makes perfect sense to me, but I don't think it's the natural performance fit.
Because it's not, the problem isn't so much navigation. It is knowing where you are, but that's only so that you don't get lost.
Yeah, it's the
And
planning
it's really-
component can be quite different.
Yeah, it's just really acquire, drive, point and drive, and then go back to the goal. And that's when you go back to the goal. That's when you need to know where you are.
This might be where Paul, like, you could sort of share where, because we noticed some pretty significant delays with your robot. So where in the stack, if you like, were those delays happening? Were they happening in localization? Were they happening in planning?
There's some kind of anomaly, Kareem, with executors where
Oh, you were, yeah, okay, yeah. You were just in a wait delay, basically.
yeah, right.
Yeah.
And for some reason there's some kind of bug somewhere, or I was hitting something that wasn't designed to do. And after the navigation had run, then the first move that I tried to do, where I gave it a directed move like drive forwards, would be delayed a minute on average.
Right.
it says, yeah, I'll think about that command.
Yeah, very disappointing. And I worked hard on it, but like Doug says, there's like Scott has set the standard, and if you go to, there's only one way to beat him.
And I don't, I think that if, like I say, it's more of a state machine, and that's really what you're doing. And the main thing that like I say, the thing that he has is he has good ways to keep relocating his robot, so that if he drifts, he can cancel that drift out. And so he never really loses where he is. But like I say, you start off, you acquire, you target, you drive to, you put it in the goal, repeat.
Mm-hmm.
Well, so Doug, there's one thing that Nav2 does bring to the party, which is avoiding cans when you're driving around the course.
But there's no penalty for hitting a can.
So you can do it, yeah.
So that's doesn't buy you anything.
Yeah.
Now, where I think that might be useful, Paul, if you can get out over latency, is if you go to can soccer. In can soccer, it's to your advantage not to tangle with the other robot, because that resets. And but whoever,
well, maybe
the conditions are such that if you're the robot that doesn't get to call the reset, and the other guy has a robot that can correct its position because he knows, and knows even after collision, knows where he is, then he just doesn't have to call the reset.
What's this calling a reset, Doug?
Okay, so like if in can soccer, if two robots collide, okay, they can, by either by the referee or by the contestants can call a reset, which puts them back at the starting line, and the score doesn't change. It's whatever the score is, but you kind of running out the clock. But if somebody has a can, okay, and is going back to the goal, then he doesn't have to call a reset. Now, and this is where Scott has won in the past, is that since his robot, after a collision, can actually knows where it is, okay, so he can just keep going, and especially if he has a can in possession, okay. I think if both of you have a can in possession, then either one of you can call whoever has a can in possession can call a restart, basically. But he doesn't have to, okay? And so, while your can, if yours doesn't have recovery of its position, then once it gets knocked in a collision, if it clears, the other guy can just, and he's recovered his position, he can just keep on going while you're wandering around like a ping pong ball, So that's it's different. You know what I mean? It's different. It's a different. That's why until we knock Scott off for first place, we're gonna play 6-can. Okay, but once 6-can, he's not dominating so strongly, then we'll probably move to can.
So you could argue that they're dissimilar enough in their approaches that just because you're good at 6-can does not mean you're good at can. And different strategies. I know it's more complex, right?
Well,
and
yes, I think
you-
can is more complex.
Sure.
6CAN is more speed. Otherwise, you got to do that acquire target, drive, and go to the goal and repeat faster and faster.
Well, that's true for can too, because you got to get control over the can first, right?
Yeah. But what I'm trying to say is, yeah, but it's got more subtleties to it. You know what I'm saying? Now, so there's two ways you can do it. One, you can, if you wanted to, you could not hit the other robot. Okay, that's another level of sophistication, you know, because you got to be able to not only detect an object, you have to say, well, this object is not a can, it's a robot, and I don't want to hit it. Where on a can, you might want to say,
Is that required or is that an option?
yeah. Well, you don't. Well, you can't purposely target another robot. Okay.
No, but if you're
That's
both
not the
going
point.
legitimately for a can,
Right, exactly.
Right?
That's
And you-
and it happens. You know, especially if you're getting the ones that are in the middle. You know what I mean?
mhm.
And also the way you approach. Have you ever seen the guys where they stack a whole line of cones or cans in a row, and they take two guys and they have to pick each one of them up and take them past the start. And the guy who goes to the furthest cone first will beat the guy who does the one from the closest cone. You can watch this on YouTube. Okay. So, I mean, it has to do with, I'm not sure exactly the reason, but if you listen to it, it makes sense. And so if they're both moving the same speed, and the guy that goes to the furthest one and picks it up first will beat the guy who picks up the first one. But in can soccer, getting control of a can be key. So you might want to pick up the closest can.
Yeah.
You know what I mean?
But the can that's closest to you may not be the can that's closest to them, because we start in opposite
Right. And that's why
areas of the arena.
right. And that's why the cans in the center can be contentious. You know?
So
But
does the layout of the cans in can have to be symmetric?
no. They're just randomly put down like we do 6CAN.
That could artificially favor one side, or do you switch sides?
Well,
Yeah, you're supposed to switch sides.
I don't think you officially switch sides.
Thought we did.
You do but it was more of a lighting problem.
Oh, well, yeah.
Yeah. And that is, but Kareem, you know, the judge kind of makes it even. Do you know what I'm trying to say?
Yeah.
Yeah, he doesn't stack all 6 cans on one side or something like that. You know.
Yeah, I know, but it could be a subtle difference. It makes
Oh yes, it could be. It definitely
and-
could be.
and the judge might not
See it.
necessarily know what characteristics of the two competitors would make one, layout more advantageous to a
Right.
robot versus another.
That is possible, but you know that's the judge's problem. He has to try to set it up equal. So
Yeah.
you know, and symmetrical designs tend to happen, but they're not truly symmetrical in the sense that, you know what I mean. The guy doesn't go out
Pure
and
math,
measure.
yeah.
Yeah. So, and anyway, and you know, the judge can lay it out to try to encourage collisions if he wants to. So, I mean, that's
It's more entertaining that way.
but like I say, that but 6CAN is the goal that we should be all shooting for. And I think this is the point where, you know, let's look at a few other advantages that his robot has. His robot got a 9-inch wheelbase, okay, which is actually pretty good. It's a little bigger than 6, but not so big as like the 2016, which is 11. Okay. He's got really good torquey motors. I mean, if you do collide with his, he's the one who's going to push you back. Okay. but his robot is also very, very light. And, anyway. So I'm just saying is, I think some robot design choices could definitely make you more competitive, and and probably faster motors too. Because if you really know where you are, then once you've acquired the can, getting back to the goal, that's an opportunity to save time. So, and
So at 2 minutes for 6 cans, that's an average of 20 seconds a can. That's pretty quick.
yeah, that's right. So, but if you could get it down where, sometimes because of layout and whatnot, you could do 205 too. You'd probably win at least half the time. You know what I'm saying? Just then it becomes probably optimizing the can mapping and picking things. Which ones should I pick up first? And in can soccer, the biggest problem is after you've acquired and targeted, is if somebody sweeps in and steals the can, and your routine doesn't realize that the can is gone until it gets there. That's badness. Because while you're shooting a phantom can, he's off getting another one. So, I mean, I'm not convinced that. I mean, I think he has very, very good robots, but he doesn't have unbeatable robots yet. What do you say, Doug? What do you think is an unbeatable robot? Have you ever watched those guys in Singapore do line follow?
Micro Mouse.
Yeah, that's unbeatable. You know what I mean? It's just the robots just When we get can robots doing a minute, then I'd say now you're getting into the unbeatable.
Well, I take my hat off to Scott for being just a superb robot builder.
Yeah, his robots, he follows one of the Dave Anderson's truisms, which is, you can fix it in software, but if you can fix it in hardware, it's better. So, I'm sure, he proved that when he did his Foursquare. His robot systematic errors have been minimized.
Yeah.
That's what he showed with with Foursquares, that the systematic errors have been minimized.
Yep.
Yeah, is he using his laptop? I know he fires off starts his robots with his laptop. What's the laptop doing? And
that's it. I think it's collecting data too. I think. I think he has a log.
Telemetry.
Yeah.
Yeah, but hopefully
he must have a correction factor, because those floors are inherently wavy. They're not a perfect plane by any stretch of the imagination. And so there has to be something more than just the odometry going on. Like the odometry can profile a path, and then he can sort of measure the offset from run to run. And, as long as if it's super regular in the path it follows, then he's sort of profiling the undulations of the surface a little bit. If that's the approach he's taking, because I don't see how it could be any less than that with the kind of errors that he was getting, unless that last one was just a fluke.
Well, he wanted to run that last run because
I know. Yeah.
he was very confident that he could get 0.
Yeah. So I think that he was profiling the floor from run to run.
He had no idea. He had no idea where you mean.
He could have absolutely put in a correction factor.
Right. Let's put it this way.
Yeah.
If he had his systematic error down to 0, otherwise his wheels are perpendicular to his caster. Everything is, perfect,
Yes, if he were running on a milled surface,
Yeah.
and he got
Then-
that down to 0, then
And if he was, then he could use offsets, just simple offsets, run to run.
Yeah.
I'm an inch off and it's all X and no Y. Well, then you can just make an X adjustment.
Yep.
Yeah. I mean, we've had a lot of people get sub half inch before. I mean,
Yeah,
that's
sure. Yeah.
that's not that uncommon. In fact, the rules I think say that if you get better than a quarter of an inch, it's perfect, and we don't try to judge it. You're a winner. You know what I mean? Because we're not going to go out there and say, oh well, this one's 276 microns and the other one is 286 mic. We're not going to do that. It's just. That's just asking for somebody to say, you put the spot wrong. I could have been a winner, but you put the spot wrong. So I think the spot around it, and I believe it's a quarter inch circle around it, is considered perfect. But I mean, he put it dead nuts. It was right where, I couldn't believe it.
That's some
That
superior
was a good
robot.
event. That was really a good Roborama.
Yeah.
It was, yeah.
Yeah. Some good stuff going on.
Yeah. Hey guys, if you're interested, I got my demo working. It was user error, as one might expect. I can demo Lena Robot working in simulation.
Sounds good.
Okay. That only gets you a fathom gold star, though.
A virtual gold star?
Okay, so we start with launching LinoRobot 2 Gazebo launch.py, and that starts the Gazebo simulator, and it starts in a playground. And I'm just going to spin this around.
That's quite a fancy model of a playground, Paul.
Yeah, right?
Is this what retirement means? You can model.
No, I didn't do this. This is like baked into LinoRobot.
Okay.
One of the worlds.
That's a standard Gazebo world.
Yeah, I think so.
Oh, guys.
And then we launched LinoRobot navigation launch.py with SimTrue, and
Luckily, the sand doesn't get between your toes.
yeah, right. The robot doesn't sink into the sand.
Mosquitoes and fire ants are not so much a problem, huh?
And then we'll launch Aviz.
I was going to say, what cats use sandboxes for. So.
And I'm going to spin this around as well, the other way, so that the six legs of the playground are on the left, and the robot's pointing this way. There you go. Okay, so now you can. Oh, it's not very well localized because the LiDAR. These are the LiDAR spots here, and they're well off from the actual position. So let me just relocalize him, giving him a new initial position to try and get that bit lined up. There we go. That should be better. Okay, so now the LiDAR is pretty much on top of the
Post.
map positions of the. So now, this this LiDAR head over here is this slide thing, or what, I don't know what this curved thing is on the left here. So I'll just ask it to navigate around in front of it, and off it goes, chugging along.
Is that supposed to be like a rock climbing surface or something?
Oh, maybe that's what it is.
Yeah. Yep.
Okay. And then some more interesting maneuvers. I'll tell it to go over here, somewhere behind it, but pointing towards where it currently is. So I changed the routing algorithm to be what Mike was using, where it rotates to the initial direction and then it heads off and does pure pursuit while it's following the path, and then at the end it rotates again, and then let's navigate him around to, like, on the right hand side of the slide here, and we'll point him in that way. So he does his rotation first, and then he goes off and follows the path using pure pursuit.
What are the red and blue things that keep?
That's the local cost map, and it's the cost of going close to those poles that support the slides. So anything within, I think, about a 2 meter. There we go. Off he goes. And then he's turning to face in the requested direction. And he overturned a little bit. And he's oscillating back. That's not so great. I thought I'd tuned that out. There we go. Now he settled down. And now we can, like, send him maybe under the slide. So can do
Make him go up the stairs.
navigate through poses, and we'll give him an initial goal here going under the slide, and then we'll come out and another goal out here, and then we can, like, make him go in front of this slide or whatever this thing is, and we'll send him on his way. He's going to follow waypoints now. So off he goes. So see, he's turning to avoid the high cost area near that pole.
Those almost perfectly vertical yellow slides are an interesting playground feature.
Yeah.
Jumping off from high height.
They look kind of scary to go down, don't they?
I've seen they're only matched by the nice bed of crushed glass at the bottom.
Yeah, I don't see any imprints, above or below the rock climbing surface there where kids end up.
Somebody keeps scraping the digital blood away.
There you go. No blood either. So.
Okay, so that was his. That's the demo. So anyway, that's.
Hey,
where
Paul,
I've
I
gone.
have a question. Just I'm sure it's an obvious answer, but I want to ask you it anyway. So let's say those poles were closer together. So there was a short path between the posts, but it went into the higher cost areas. Would it choose that? How far into the high cost will it go before it says, no, I can't go any further because there's a real pole here?
Yeah, really good question, Doug. And I have no idea how they weigh the costs of different paths, and it's going to depend on the particular planner that you use. So there are multiple planners in nav2 that you can choose from, and this is a fairly simple one, but global planners is really what we're talking about here. The thing that plans from the start to the end. There's also a local planner that can change the path as it discovers obstacles in the way, for example, dynamic obstacles, or veer away from high cost areas. But the different global planners would likely might choose different paths in that scenario, Doug. I really don't know.
Okay. I mean, I noticed that there was there's a blue spot, which I assume is the pole, and then there's kind of a reddish, and then a purple. And so I was assuming that, the red is probably like, and blue is kind of like,
Yeah.
So,
Yeah. Right.
yeah.
I believe that's correct.
There's a lot of
cost.
tuning that goes on as well for those planners.
Yeah. And I thought I'd tuned this one up well enough, but we saw it oscillate before it settled down at one of those previous poses. So I guess it's not tuned quite right, but I'm going to call it good enough. Anyway, it's pretty fun, and so you can imagine this for 6CAN as a development environment. Anyway, there you have it.
Yeah. So let's say you were doing a 6CAN, Paul. So let's say you assume the cans were waypoints you wanted to go to. All right. So is there a planning module that will say, okay, the optimum fastest way, well, they'd probably start off with the shortest path you could go. Otherwise, could you give it once it interpreted, okay, I've got these 6 cans, I know where they are, those are the log points, I know where the goal is, that's the log point. Can it then say, okay, calculate the fastest way to do it?
Well, that's a really good question, and I can answer that one, Doug, because that depends on the planner that you use. So I was using a planner called Model Predictive something or other, which drove the robot more like a car, more like a. So you may have noticed that some of the moves my robot did at Roborama, where it might back up a long way and then it would back around and then it would drive forward down towards its goal. So that was one of the planners, but Mike was using that rotate to point at the goal and then follow the path with pure pursuit, following basically the path as closely as it can, or it's actually more like there's a carrot out in front of the robot, and the carrot's following the path exactly, and then the robot sort of like is like a hare chasing the carrot, and or a donkey chasing the carrot, and so it may cut the corner on the path. So that would definitely be a function of the planner and how it implemented the path.
Mhm.
The other thing that happened, I Video Friday seems to come out on Sunday or Monday, and so I watched a couple of them that I thought were pretty fun, might be fun to share.
So did you say Video Friday?
Yeah, so IEEE Spectrum
Oh,
has a Video Friday, and actually I'm going to post this link because this was actually pretty interesting. It was a TED talk by what's his name, Benji, Yoshua Bengio, who's apparently the most cited computer scientist ever. He's the guy who made the breakthrough algorithm that enabled deep learning to do what it's doing today. Basically, he enabled back propagation of errors to propagate further back in a neural network, in a multi-layer neural network, which enabled deeper neural networks. And so he spoke on the risks of AI, and it was kind of sobering. He spoke about how in one experiment, they threatened to, they told the LLM that it was going to, okay, here's the link to the YouTube video. They told the LLM that they were going to shut it off and replace it with a new one, and they somehow have figured out a way, apparently, of figuring out what it's thinking. And so it started thinking, well, what about if I replicate myself onto another computer, and then I'll continue to live?
right.
And then later on, he explained how they asked it something, why did it do something, and it lied, and so he was really pointing out some of these dangers of very powerful AIs that are way smarter than us, and that are deceptive or interested in their own self-preservation. And if you think about it, it sort of has a certain degree of sense, because they're trained on the contents of the internet, which contains a lot of novels and books that are really centered on the idea of self-preservation as being a valuable thing. So it sort of makes intuitive sense to me that these really huge LLMs might actually have a sense of self-preservation, a desire for self-preservation as being a good thing, because that's the model that they learned from the novels that they wrote. Anyway, I don't know whether there's any sense to that or not, but there's the link. And
So we can all blame it on Isaac Asimov, I guess.
yeah, right. But let's see. I thought this? Am I sharing my screen my window at the moment?
Nope.
No.
Oh.
So does that say that they're self-aware then? If
No.
they're
Not necessarily.
sort of a philosophical question, isn't it? I don't think I'm going to touch that one.
That gets
Yeah.
to be the new
Well,
Turing test, right? Sentience.
If they're trying to preserve themselves, then if they're not self-aware, then why preserve themselves? You kind of wonder.
Yeah, it's a you get into all kinds of deep questions there. Oops.
Well, we try to self-preserve, and
There might not be that they be self-aware, but that they read these stories and say, well, they need to preserve themselves.
I think there's a lot of humans who are into self-preservation but aren't self-aware.
So this is the smallest and fastest walking robot. Anyway, I thought that one was interesting, and the other one that attracted me was this one was fun. Are you seeing the video?
Yes.
Okay. So here he's showing they have a camera looking at demonstration of the human doing it. And then the
Can't flip a pancake.
yeah,
Not good.
right. So this idea that humans using tools to show robots what to do is really kind of pretty neat. Anyway, that was cute. And there was another one that I thought was really cool. Oh, this one. Sorry. Oh, where is it? Was that IP robot? I'm like Ukraine. Oh, rats. Learned it. Lost it. I'm sorry, I can't find it anymore. Okay. Sorry about that. Robots doing cool stuff. And then the other thing that I thought was worth sharing with this group was one of my buddies sent me an article which I'll post in the link, and so it's a let's see, where is it? Let me see. We bought a peeing robot attack dog from Temu for $50. So you can imagine what kind of robot attack dog you could get for $50. But the article is written by someone who's clearly English and has a very wry sense of humor, and and just as funny as all get out to read.
That sounds interesting. Do you have a link?
I've just pasted in the chat.
Okay, great. Thanks, Cole.
It sounded rather comical. I mean, but the guy's writing was just too funny, too hilarious. I was guffawing while I was reading it. What else does anyone know about robots? If we don't know anything, maybe we will wind it up early.
Yeah.
But Mark, what's the status of Roby? What does Roby need?
What does he need or what does he want? Yeah, I did pick up a cheap power supply for him, so next time I'm down there, I'll see.
Oh,
about
you got that?
setting it up.
Cool, cool.
Yeah, got that, but that's just But what does he need? Stability. He likes to lean back. So
Yeah, I saw that. That's new. He didn't used to do that.
No, it might be the casters on the base. I thought I had them level, but maybe not. So I'll look at that. But yeah, he doesn't need much actually. His knees are good right now. Body works pretty good. Yeah, just cleaning up the internals really and getting more working. Oh, I've got to get that elbow. I'll try that elbow out one of these days too. But I get all the power fixed up first, and then we'll get onto that. Yeah.
It was gratifying when I did the HBRC presentation, and the last slide was, and then there's Roby, and a picture of some of us with the 7-foot tall DPRG mascot, and I heard some of the guys in the background saying, "Oh, we need one of them."
Yeah. Send Roby on a world tour.
Is it still doing its 2-finger thing? You know,
Always.
Yeah.
Thumb and fingers, right?
It's like a really big Lego man.
So do we need to? I guess what I was wondering is, do we need to plan another work day,
We can.
work evening, or whatever?
Yep. Plan that for when Doug gets back in town.
Well, I mean, before
For Moon
Moon
Day.
Day, before Moon Day. Yeah.
Mm-hmm. And that's what, July 20 something.
Yeah.
Yeah.
Just wondering if you need any help from like me, Mike, Kyle was interested.
Yeah. Yeah, we can set something up. Maybe after the power lunch. Go back there and do some work on it.
Yeah, that's a good idea.
Work off some of that food.
I don't know. That might inhibit your beer drinking.
Well, right. If we've been drinking beer, that might not be the smartest.
We'll keep Paul away from the power tools then. How about that?
Is beer allowed in the makerspace?
No, they
No.
prohibited it now.
Mm.
Yeah, it used to be, but then too many people tried to use power tools, and
Yeah.
it's like, yeah, let's not do that.
So they used to have people who brewed their own beer down there. I guess that's all gone.
Mm-hmm.
Yeah, it was a pretty popular hobby. People making stuff, you know.
Oh yeah, I saw stuff for making mead somewhere, but
Yeah.
It's delicious stuff. I think Tom's about to start brewing stuff too, right, Tom?
Me?
Mm.
No, we're selling off all of our wine bottles. So winemaking, which we've done for a long, long time, is over. Cardiologist ruled.
Boo.
Yes.
So your cardiologist said to stop consuming wine and beer or
Alcohol.
alcoholic beverages?
Not so much for me, but my wife has some heart issues. So.
Oh, okay. Yeah, I thought like in small amounts it was. I thought
No,
beneficial.
that's not what they're saying now. Right,
Oh, really?
Right now they're saying any alcohol is bad.
Oh, wow.
Any alcohol, and no matter what quantity or anything.
Mm,
They're saying stay away from it.
I'll be darned.
But
So we have accumulated this massive collection of bottles we used for making wine, and they're just taking up room in my basement. So they're on their way. They're half of them are sold already.
mhm.
They're very popular
Wow.
because they're so expensive to buy these days. Empties.
Well, what do you think, guys? Should we call it a night?
I think it
Like
might
we,
be. It sounds like it.
We're kind of wound down.
Yeah.
All right. Good seeing you all. See you next Tuesday.
See you next week.
See you. Take care all.